So this video is for page 6 of your packet, and we're just going to review how to simplify something now that is a cube root. So before we get started, I just want to remind you guys that this symbol is called the radical, and you're used to just seeing it for a square root when this is technically a 2. This number up here is called the index, and we are now focusing when the index is a 3, and we are finding cube roots. So first, if you want to pause the video, I'd like for you guys to just fill out like 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, and so on. Just go ahead and pause the video and fill that out. And then when you hit resume, I'll reveal the answers. All right, so here's the list that you should have generated, and hopefully you hit pause. If not, you're just copying away now. But these are something called the perfect cubes. Just like on page 1, you came up with the list of perfect squares. This list that you just came up with is called the list of perfect cubes. So I'm going to walk you guys through the first method, and then I'm going to show you guys the shortcut. So instead of knowing the square root of 16, we now want to take the cube root of 16. 16 is not a perfect cube. There's no number times itself 3 times that gives you 16. So we're going to do one of our prime factor trees, and this time, since our index is a 3, we're going to look for triplets. So within the 16, there is actually a 2 times 2 times 2. That would be the 8. And the cube root of 8 is 2. So I pulled out this 2. And then this 1, 2 is left underneath the radical, and it's called the radicand. All right? So it's the same concept. You're just looking now for triplets. Now for the next one, 54. So 54 is not in our list of perfect cubes, so we can simplify it. So it's 2 times 27. Which is 3 times 9, which is 3 times 3. And in this list, we have a triplet that we can circle. So 3 times 3 times 3 is 27, and the cube root of that would be 3. So this is the 3 that we pull out, and then underneath the radical, we have this 1, 2 that we leave. Friendly reminder as you're writing your answers, folks, not to forget to write the index in your final answer. You should have a little cube up there for cube root. All right, now for the third example here, 375 is not even, so we don't start with a 2. But when we add them up, it is divisible by 3. So 3 times 125, which is 5 times 25, which is 5 times 5. And right here we have a triplet, so the 5 comes out and the 3 stays in. For the next one, 320 is an even number, so 2 times 160, then 2 times 80, 2 times 40, 2 times 10, 2 times 20, then 2 times 10, then 2 times 5. So here we've got one group of 2 that we take out. That's the first number you see. Then I have another group that I take out. That's the second 2 that you see. And then we just have this 1 5 left over. So 5 is my radicand. Now on the outside, if I pulled out this group of 2 and another 2, I've pulled out 2 times 2. I've pulled out a 4. So this final answer is 4 times the cube root of 5. Now for the final one, 162. It's even, so 2 times 81, 3 times 27, 3 times 9, now 3 times 3. And we have one triplet. And left on the inside, we have a 2 and a 3. Now another thing I want to mention, y'all, is it doesn't matter if you have this 3, and this 3 circled. It's okay to circle these 3, and then you have the 2 and the 3 right here. Doesn't matter. But you have circled a group of 3, so it's out. The cube root of this 27 is 3. And then you have 2 times 3 left, and so the radicand is a 6. Now I'm going to come through and show you guys the shortcut, and you're less likely to use the shortcut here because you probably don't have this list of perfect cubes memorized. But 16, for example, 8 is a factor of 16, and it is a perfect cube. So 8 times 2 gives me the 16, and since 8 is a perfect cube, if I take the cube root of it, I get this 2, and then I have the 2 left underneath the radical. Same thing here for the next one. 54 is the product of 27 and 2, and 27 is a perfect cube. So the cube root of that 27 is 3. That's out here now, and then 2 is on the inside. For the third example, 125 is a perfect cube. That is a factor of 375. So we've got 125 times 3, and the cube root of 125 is 5, so it's on the outside, and then times the cube root of 3. For the next example, 64 is actually a factor of 320, and it's 64 times 5. So we know the cube root of 64 is 4, because 4 times 4 is 16. Times 4 again, you'd get 64. And then you leave the 5 underneath the radical. And for the last one here, again, you probably wouldn't know this, but 27, which is a perfect cube, it's 3 cubed. 27 is a factor of 162, so 27 times 6, and the cube root of 27 is 3, and so then we leave the 6. Because you probably don't have this list of numbers memorized, method B here, our shortcut, is not going to be very natural to you. So the process over here of just making the factor trees and now looking for groups of 3 to circle out, that's going to be what you likely want to learn to do. Okay? And that concludes the video on page 6. Thank you.